Okay, so for number 3, we're trying to find a power series, in this case a Maclaurin series, representation for the following functions and determine their intervals of convergence. So the first one we have is negative 2 over 1 minus x quantity cubed. So what you have to realize for these types of problems, or what you have to recognize, is that this is going to be multiple derivatives of the one form that you do know. Remember that you should know that 1 over 1 minus x is the series x to the n equals 0 to infinity, with the interval negative 1 to 1. So that's one of your 6 power series representations that you should have memorized. So remember that if you have anything other than x, it's just a substitution in there. So if you had 1 plus x, you would just put minus x in there. A bunch of things you can do with that. So this one is not of that form directly because we have 1 minus x quantity cubed. This is going to have a lot of terms if you've expanded that all out. It's not going to look like this at all. But what you want to recognize is that the denominators are the same, except this denominator has a couple extra powers. That's the hallmark of this is a certain amount of derivatives of this function. Because if you took the derivative of this function, the power of the denominator would get bigger every time. So if this denominator has power 3, this denominator has power 1, this is going to be some type of function that's 2 derivatives of this. So what we want to do is let's just start with 1 over 1 minus x. We know that function already. Let's take its derivative. So keep in mind, this is the same thing as 1 minus x to the negative 1. So when you take the derivative of that, you're going to get negative 1 minus x to the negative 2, times negative 1 due to the chain rule. So it's still going to be positive because you had 2 negatives canceling out. Alright, that increased our power of our denominator by 1, so now we're closer. So now we need to do it one more time. Actually, let me still write this here. So in doing the derivative again, remember that this can also be written as 1 minus x to the negative 2. So we're going to bring down negative 2, 1 minus x to the negative 3, again times negative 1 because we have an inside derivative that's not just 1. Negative 1 and negative 2 combined to just give you 2, 1 minus x cubed. And now we're similar enough that we can do this series. So what you can see is the series that we want to find the power series representation for, or the function that we want to find the power series representation for, is 2 derivatives of the one we know, and then it's going to be the negative of that. Because 2 derivatives of the one we know gives us 2 over 1 minus x cubed. We want negative 2 over 1 minus x cubed. So once we take 2 derivatives, we just tack a negative on, and then we'll have the series for this. So let's take the derivative of that. So the first derivative gives you the following series. Instead of x to the n, you would have nx to the n minus 1. The derivative of x. Here's the thing though, you want to start this now at n equals 1. Because if you chose n equals 0, the first term is just going to be 0, and that's kind of a waste, it's useless. So we bump it up to n equals 1. Taking the derivative is not going to change your interval either, so we still have the interval negative 1 to 1. Okay, we know we need to take 2 derivatives, so let's take the next derivative. So our next derivative, the n is a constant, so it would stay there. We bring down the n minus 1. X now has a 1 lower power, n minus 2. Again, for the same reasons, we want to bump this to an n equals 2. So that we don't just have terms being 0. Alright, so this is 2 derivatives of this function. And then we need to just make it negative, because that's all we need to do to get to the one we want. But there is one thing we can do. We can reorganize this, and this is how you would see this usually if it was a multiple choice question. You always want to try to get the starting n of the series to be 1 or 0 if possible. So you can shift this so that your n does start at 1. So first of all, like I said, we want to put a negative in front of this due to we need a negative sign on ours. So if we started at 2, we have n and n minus 1. That's the same thing as if you started at 1 and had n and n plus 1. So starting at 1, you have the term and the term after it. Starting at 2, you have the term and the term before it. Those match up for all n. And then instead of saying x to the n minus 2, we could say x to the n minus 1. So if that confused you, you can plug in a couple of n's here. Like the first term here is when n equals 2. If that matches when you plug n equals 1 to this, then they're the same series, and on and on and on. So the first, second, third term of this are the exact same as the first, second, third term of this. It's just that you started with n equals 1, and like I said, on a multiple choice question or something like that, they're going to have the answers that all start with n equals 1 or 0. So you might have to shift around your series to fit accordingly. So what we did here is we started with the series that you should have memorized, took 2 derivatives, and put a negative sign in front, and that gave us the series representation for the function negative 2 over 1 minus x cubed.